Alright, so we are doing our last lesson in Trig, the Trigonometry chapter. This is proving trig identities. So we're looking at trigonometric proofs. Now if you remember proofs from geometry, this will be completely different. If you've never seen proofs before, not a problem. This is actually going to be a lot like when we were doing our equations with trig functions. So right here off to the side, remember that these are the trig identities you're required to know. Now, I specifically told you last time that these were the three we didn't need to use. The problem is I cannot find anything trig identities wise that uses these without using these, except for on practice final exams for your class. Even the examples they tell me to use involve these three, but they don't use these three on your final exam. So this is what we're going to do. Every time we see one of these three, we're going to replace it with these. So every time you see a cosecant, CSC, just replace it with 1 over sine. Every time you see SEC, or secant, replace it with 1 over cosine. And every time you see COT, or cotangent, replace it with 1 over tangent. Okay, and then we're going to do it using just sine, cosine, tangent. Also, every time you see tangent, go ahead and change it to sine over cosine, because in the end, ultimately, we want everything to be sine over cosine. Alright, so number 1, right off the bat, we see CSC right there. So that's the first thing we're going to do, is we're going to change this to tangent squared x cosine squared x over 1 over, alright, it's cosecant squared x, so we're changing that to 1 over, so cosecant is 1 over sine. Now because it's cosecant squared, I'm just going to change it to 1 over sine squared. Okay. Now this looks like an equation. It is not. This is not an equation. Write that. Not okay, not an equation. What that means is I cannot add things to both sides, subtract things to both sides, do anything that I could do for an equation. I'm not solving this. All I'm doing is applying trig functions to this side, maybe applying trig functions to this side, and I'm just trying to make them look the same. All I'm doing is just changing either one side or the other, or maybe even both, using our identities until they're the same. Okay, so this side over, I'm going to start with the most complex side. Well, clearly this side over here is the more complex. Over here is just sine to the 4th. So I'm just going to leave that side alone. I'm going to change stuff over here until I can make the left side look like the right. And yes, I know every time I move my pen, my camera goes blurry. Alright, so that was the first thing we changed. Now, 1 over sine squared. That's a fraction inside of a fraction. We definitely don't want a fraction inside of our fraction. So let's get rid of the fraction inside. Let's multiply top and bottom of my fraction by sine squared x. Now I can do that because I'm not multiplying both sides of my equation. I'm just multiplying just this left side. That's all I'm changing. My pen's not working. By sine squared x. Do the same thing up here. Sine squared x. Okay? So multiply top and bottom by sine squared x. What does that do? Well, these cancel out. Okay, so now I just have a 1 on the bottom, so I'm not even going to bother with a fraction anymore. And I'm just going to list out my terms. I have sine squared x, I have a tangent squared x, I have a cosine squared x, and then over here I still have sine to the 4th x. Okay. Now, again, the first thing I did was got rid of, changed that. Alright, didn't want the complex fraction. Remember I also said every time we see tangent, we're going to replace it with sine over cosine. Well, because it's tangent squared, we're going to change it to sine squared over cosine squared. So let's change that. Sine squared x So this is sine squared x over cosine squared x. Then we have a cosine squared x equals sine to the fourth x. Beautiful. All right. Now what do we do? Well, I have a cosine squared x in the bottom, and I have a cosine squared x here. Well, multiplying a denominator by itself just cancels out. So those two cancel each other out. The blue pen's really not working. And I'm left with sine squared x times sine squared x equals sine to the fourth x. Okay. At this point, it's probably fairly obvious that sine squared times sine squared is sine to the fourth. So all I need to do is rewrite it. Sine to the fourth x equals sine to the fourth x. And there we go. The whole point of this was to make the left side and the right side the same. Notice I didn't move stuff back and forth, not an equation. Didn't do anything like that. I didn't change the right side of this one at all. Okay, I just changed the left side until it equaled the right side. Okay, so this is a proof. All right, proving an identity. Now, you don't have to do this in this class, but generally with an identity, you put some kind of mark to show that you reached the end. Now, that's not like an exact same mark for every one. Usually the marks differ. Sometimes you'll see 3 dots. Sometimes you see a little box, an open or close. In my pre-cal class, I would tell them that that's like a mathematician's signature. You kind of sign to show that you finished the end of your proof. Okay, so I would tell them come up with your own kind of signature, and I'd have students do like smiley face or whatever symbol you want. So I'm just going to do very boring, typical mathematics signature of the 3 dots at the end. But some other examples that are common is drawing a little box, sometimes a colored in box, yeah, whatever, some kind of shape, some kind of symbol at the end that shows that, oh, there we go, I've reached the end of my proof. Okay, there we go, that was the first one. Let's come over here to this one. Alright, right off the bat, I'm looking for any trig function that's not the one I'm going to normally use. I'm going to do 2 things here, okay, and it's okay, I can do 2 things. Minus, I'm going to change the secant. Well, secant is 1 over cosine of x. Okay? And I said 2 things because, remember I told you every time you see a secant, cosecant, or cotangent, you change them. And every time I see tangent, I'm going to change it to sine of x over cosine of x. Alright, so I changed both sides on this one. Alright, well, this one's a super easy one. Hopefully you kind of already see the answer to this one. I'm actually 1 step away from being done. All I'm going to do is say, well, sine, I can multiply something by a fraction by just multiplying it to the top. Well, 1 times sine of x is negative sine of x over cosine of x. And then over here I have negative sine of x over cosine of x. And there you go. Put my 3 dots or whatever you want to use, and I'm done. Next one. Alright, again, let's think about what we're going to do first. I see a tangent, so we're going to change that. I see a cosecant, I'm going to change that. Over here, sine and cosine, I'm going to leave those alone for right now. So let's change the tangent. The tangent is going to be sine, is a tangent squared, so sine squared x over cosine squared x. And then I see a CSC, so that's 1 over sine x. Alright. Equals, and I'm leaving this side alone, not touching it, changing it at all. Okay. Alright, what do I do next? Let's see here. Let's combine these fractions. Just multiply across. sine squared times 1 is sine squared x. Cosine squared times sine, I'm just going to leave it cosine squared x sine of x. Well, here, sine squared, that's a sine times a sine, and I have a sine on the bottom. So, cross that sine off, cross one of those off, and so I end up with sine of x over cosine squared x and yes, I realized there was a square, should have been squared right there too. And there we go. We got them, both sides to be the same. Alright. Alright. So that's using just changing them to sine and cosine, combine some stuff, cancel out some stuff, done. Alright. So for these, we're going to try to apply some of our Pythagorean stuff, but the first steps are still the same. So step 1, I see, okay, secant. Let's replace that with 1 over cosine squared. Cosecant, I'm going to replace that with 1 over sine squared. Alright. And then, pins. Let's try this. Secant, okay, I'm going to replace that with 1 over cosine squared x all over sine squared x. Okay, what next? Well, I have a fraction plus a fraction. So to add two fractions together, which I got to add them together because over here I don't have something plus something. So to combine those two fractions, I need a common denominator. Okay, common denominator. Well, this one has cosine squared. This one has sine squared. If I just multiply by both of those together, I'll get cosine squared, sine squared. That'll be my common denominator. So this fraction, I need to multiply top and bottom by the opposite denominator. And that confuses you. It's the same thing as saying if I have 2/3 plus 1/2. Camera focus. There we go. If I have 2/3 plus 1/2, I need to get a common denominator, and my common denominator would be 1/6. I'd multiply this side top and bottom by 3. I'd multiply this side top and bottom by 2. Okay, that would give me 4 over 6 plus 3 over 6. And then I could add them. I'd combine them, leave the denominators alone. 4 plus 3 is 7. Alright, so that's how we add fractions with numbers. Well, the same thing applies when I throw trig functions in them. Alright, so let's see here. This one multiplied by sine squared x. And then this side right here, cosine squared x. Okay. And so after I do that, I end up with sine squared x over sine squared x cosine squared x plus cosine squared x over sine squared x cosine squared x. Beautiful. What about the right side? I have a fraction inside of a fraction, which I don't want. So let's get rid of that. And let's get rid of it by multiplying by cosine squared x. Okay. So those cancel out, and I get 1 over sine squared x cosine squared x. Ooh, notice all my denominators are the same. There we go. We're moving in the right direction. Alright, but because I have the common denominator here, I can add those two fractions and say this is sine squared x plus cosine squared x all over sine squared x, not plus, times cosine squared x equals 1 over sine squared x cosine squared x. Okay. Now we are actually at our last step And the reason why is, if you remember, our Pythagorean theorem says cosine squared x plus sine squared x equals 1. Well, I'm going to use that because I have sine squared and cosine squared right there. So I'm just going to replace those with the number 1 and say 1 sine squared x cosine squared x 1 and my little symbol, and my proof is done. Now at this point in time, I know you're asking, well, if the only thing is I have to make both sides the same, can't I just rewrite the left side and just say, alright, let's change that to secant squared over sine squared x, and then boom, I'm always going to be done. And no. The people grading this are going to know what your trig identities are. They have to be able to follow a logical progression. If you do a step that's not using a trig identity, then they're going to know it, or in your case, I'm going to know it, and you will get it wrong. So, no. But you can, very much so, use that to your advantage of knowing, okay, I got to get from here to here. So you can use that to help you remember some of your trig identities. Not that we have that many to remember anyway. Alright, so first thing, I'm going to change all this stuff again. This one actually looks a lot like the last one, like almost just like the last one. So I should have been saying this all along. As I'm doing these, why don't you go ahead and pause the video, try this one if you haven't already. Hopefully you've been pausing the video all of this entire time and trying each one before I do it. But if you haven't, definitely go and try this one because this one's going to work just like the last one. Alright, so hopefully you followed those steps as I was writing them out. So the pink one, I just replaced everything. And then going from here to here, what's in pink is what stayed the same. What's in green is what changed. So multiplied both sides by sine. This one multiplied both sides by cosine. And then this side I multiplied both sides by sine, and that's why I have a sine in the bottom. And there we go. Alright. Now that is about as condensed as you're going to want to make these. So if you err on the side of showing more steps than you think you should, as opposed to showing less, because again, these aren't graded necessarily by a final answer as opposed to your steps. So you want to make it really obvious what you're doing. I probably would have, if I'm doing this one myself, I would probably actually make it more obvious what I was doing. I kind of condensed, especially in here, just because I had literally just done those exact same steps on the previous problem, so I didn't show those out super well because I already showed those to you. But but I would probably write those out much clearer if I'm doing this as my test, and because I want to make it very obvious what I'm doing, because that's what I'm being graded on. I'm not being graded on the final answer. I'm being graded on showing my steps. Alright, last one. So here we have no sine and cosine, so I'm going to change the cotangents twice. Well, here actually, I'm going to do this. Remember that cotangent, what was this? Tangent is sine over cosine, and cotangent is the reciprocal of tangent. Well, if cotangent is the reciprocal of tangent, that means that cotangent is the reciprocal of this. Cotangent is cosine over sine. So you can go ahead and use that kind of as a shortcut here. Otherwise, it would take me like 3 steps to go from cotangent to this, which we can do, but just to save time, let's just go ahead and say cotangent cosine over sine. Secant 1 over cosine Alright, so what do I do next? Well, right here I can say, oh, cosine, cosine, they cancel out. Alright, that gets me there. Well, what do I do next here? So there's actually a couple ways I can go about this. In most of these identities, especially when we get to ones that have a little bit more into them, there's not just one way. There's multiple ways you can go about proving them. So you don't have to feel like you have to find the perfect answer. There's quite a few different ways. Over here I see one fraction and it has sine squared in the denominator. Well, right here I see sine squared, so I'm going to say, well, let's change 1 to be a fraction with sine squared in the denominator. Well, that would be sine squared x over sine squared x. Okay, so I can change 1 into a fraction real easily by just putting it as anything over itself. All right. Well, purpose of that is that now I can combine that into one fraction. Okay. And then once I do that, well, sine squared x plus cosine squared x is just 1. So 1 over. And there we go. All done. Alright, that was the last one. If you have any questions on those, email me or message me on Remind. But I think you're going to do fine. Just remember, if you feel like you're stuck, just change something. Like, so right here, it would be easy to feel like I was stuck right there. Well, just change something. Maybe you don't change what I changed. You could, there are, again, other things you could change. You could change cosine of x. So let's do that a different way. Alternate around. Okay, let's say that I changed this to 1 plus, and I said cosine squared is 1 minus sine squared. Okay. If I did that, I would then say, okay, well, 1 over sine squared x equals 1 plus, let's break that apart into two different fractions. That would be 1 over sine squared x minus sine squared x over sine squared x. And then I would have 1 over sine squared x equals 1 plus 1 over sine squared x minus, well, anything divided by itself is just 1. Well, then I have a 1 and a minus 1. Those cancel out, and again I still have 1 over sine squared x, 1 over sine squared x. So, okay, maybe I use more steps there, not a whole lot more. But again, the point is that there's a lot of different ways you can make it the same. Do something, all right? Change something, and you can probably find out what it is. Most of these should not take many steps. Right there is about as many steps as I should need for any of these.